Okay, so looking at this first page, are there any questions on problems 1 and 2? Or really, we're going to look at 1 and 2. I'm going to do these in groups of 2 for the first few, and then we'll do them in groups of 4. I'll show them up at the same time. So looking at this here, are there questions on problems 1 or 2 on how to do either one of these here? So looking at number 1, when I look at this one here, what we can tell for certain is that, well, between 6, 36, and 71, there's not a greatest common factor between any of these here. And that's partially due to the fact that 71 is a prime number. The only factors of 71 are, well, 1 and 71. So we can't simplify 71 at all. So we can't do anything with the numbers. So we can look at the variables. So we have a cubed b squared in our first term. In our second term, we have ab squared. And in our third term, we have a squared b squared. So we have all three of these terms here. Now, when we're looking through these here, these three terms, well, out of the a's, I know I have at least one a I can factor out. That's the most I can factor out. Because again, when we factor out a variable, we're looking for what variable is in common in all of them and the smallest power, because that's the most we can take out of all three. Now, we look at b, well, we have b squared, and b squared. So I can factor out ab squared out of all three terms. Okay. Now, the next thing we can do is we're actually going to go through and factor this out. So if 6, we didn't do anything with the number, so we'll still have 6. A factored out of a cubed will leave me with a squared, because I pulled one out of them out of the 3. And b squared factored out completely, because I have b squared and I factor out b squared. So I'm just left with 6a squared in the first term. Minus. We didn't do anything with the number, so we'll still have the negative 36. Now we have 1a, and I factored out an a, so that factors out completely. The b squared, well, I factor out b squared, so it factors out completely. So when I factor out ab squared from negative 36 ab squared, I'm just left with negative 36. And that brings us to the last one. We have plus 71, because again, we didn't do anything with the numbers. Now I have a squared, and I factor out a, so I'm left with a. B squared, and I factor out b squared, well, that factors out completely. So I'm left with this here, ab squared times 6a squared minus 36 plus 71a. And this here is the answer. Now in the answer key, it does say ab squared, parentheses 6a squared plus 71a minus 36. This is what it has. And it is the same thing. Now we could try to see if it does factor here. And we could try the different possible combinations, but I'm just going to check something. We'll just say b squared minus 4ac. Because the square root of b squared minus 4ac is kind of a helpful little hint, helpful little tool. Because if we're not sure something factors, we could plug this in. Because b squared minus 4 times a times c will give us approximately 76.843 this here. Now what that tells us is that, well, the square root of this gives us an irrational number, a non-repeating, non-terminating decimal, which means if I were to try to solve this here, I would get irrational solutions. Well, the only ways that we can have this factor is if I have rational solutions. I have numbers that can be either written as a fraction or as a whole number, a number without a, where the denominator is 1, where I don't have a decimal that's non-repeating, non-terminating. I don't have any radicals. I don't have any imaginary. Is the only way that this will factor. So this here is telling me if I get an imaginary number or a number that has a decimal that does not terminate or repeat, it will not factor. So this is kind of like a cheap or kind of an easy step to kind of just check and see, will it factor? Well, no. So what that tells us is that this here, either one of these here is our answer. Either one of these here is the correct answer for this one, for this problem here. Any questions on this here so far? Are we good with this here? Okay. Any questions on problem number 2? We good with number 2? Because we'll see, I think, a few more of these show up if we don't in a little bit. Okay. Questions on number 2 or problem number 3? Because I think I put down 2 number 2s. Okay. So we'll do the second 2, 4x squared plus 12x plus 9. Now, this could be one of our special ones where the set of parentheses were the same. But even if it is the case, it's not going to change what we do. Now, the first thing we do when looking at number 2 here is we want to see, is there a greatest common factor between all 3 terms? Well, there's not a number that will go into 4x squared, 12x, and 9. So I move on to my 2 sets of parentheses with 3 spaces. Now, the next thing we will check is sign. Now, since the 9 is positive, the signs are the same, and they're going to match the sign of the middle term. So we're going to have plus and plus, positive and positive. All right, now we get to the next step, the factors of the first and third term. Well, one of them is going to be a little bit easier to plug in because we know the only factors of x squared that we're going to use are going to be x and x. We have to have at least one x in both spots. And now we can look at the factors of 4, 1 and 4, 2 and 2, and the factors of 9, which are 1 and 9, and 3 and 3. So looking at this here, so for 4, do we want to use 1 and 4 or 2 and 2 first? Okay, let's try 2 and 2. How about the factors of 9? 3 and 3, okay. So when we check this here, if this works out, it means this is one of the special factors. Yep. So we'll do 2x times 3, which would give us 6x, and 3 times 2x would be plus 6x. And that gives me 12x. Is that what we wanted? Mm-hmm. So these here are our factors. Now, if you really wanted to, because I'll take this here, or we could write it as what? 2x plus 3 squared. Because since they're both the same, 2x plus 3 and 2x plus 3, they're the exact same, I could rewrite it as 2x plus 3 squared. That works also. Any questions on number 3? Okay. So if we're good with these 2 here, yes? Okay. So we switched up and I started doing them in groups of 4 instead of 2 at a time. Questions on problems 4 through 7. Any one of these 3 here we want to look at. Let's look at number 7. Now we look at problem number 7. We have a cubed plus 1. So a cubed plus 1. Now we look at this here. Well, a to the third, okay, most likely we're going to either be dealing with a sum or difference of perfect cubes. And the way that we can check this is, well, the mark of this writing, we can take the cubed root of both terms. And if I could take the cubed root of the first term and the cubed root of the other term, those 2 terms, then it is a sum or difference of cubes. Well, the cubed root of a to the third power is a. Can we take the cubed root of 1? Yeah. It'd be 1. Well, that's kind of, 1 is kind of interesting because I can take the millionth root of 1. And what is the millionth root of 1? 1. Yeah. So 1, any root of 1 is always going to be 1. So this here works. This is the sum of perfect cubes. And we call it a sum because the two numbers are being added. Okay, now we can set up our parentheses. We have a set of parentheses with 3 spaces and a set of parentheses with 5. Now we do the signs. Well, the signs follow our pattern, right? Same, opposite, always end on a positive note. So since it was plus, so we have plus, opposite would be minus. It would always end on a positive note. Okay. Now we'll fill in the first term first. So A is first because it went first in our problem. So in our first set of parentheses, we will have A. We don't fill anything in the next blank. Then we're going to have what? A squared, A, and nothing. Now we can put parentheses around this, and that's perfectly fine. Because since it's just A, it works out either way. If we have parentheses or don't have parentheses, we're going to end up being multiplying together. The key place I would put them especially is going to be when we have those parentheses squared, just as a reminder, because if it said that this was 2A instead of just A, it's a way to kind of, for us to remember, we're squaring not just the A term, we're also squaring the 2. Whatever, all those terms there are being squared. Now we can look at the other term, 1. On our first spot, we're going to have 1. We're not going to have anything with A squared. We're going to have 1 with A. In our last place, we're going to have 1 squared. So we'll have these spots here. Now, the only thing we have to do from here is we do need to simplify this down a little bit. And when we simplify it down, we'll have A plus 1. A squared as well is going to be A squared. Minus 1 times A will give me A. Plus, well, 1 squared is 1. Yep, so we multiply those middle two. So that's another reason having those parentheses, especially in the middle space here, is helpful. Just as a reminder, we're multiplying these two together. They're going to be multiplied together. Any other questions on number 7? Or we go with number 7? Yes? Any other questions on this page here for 4, 5, or 6? 4, 5, or 6? Are we good with number 6, the difference of perfect squares? Because this one here, I know you have the answers in the back, but it would be 8x minus 1 times 8x plus 1. Okay. I looked through the test yesterday, and all of them are going to be factorable in some way, shape, or form. Be that either there's just a greatest common factor that's going to be pulled out, or we can rewrite it as sets of parentheses squared, or we can do grouping. There's not going to be one that's just, this is simplified. This is as simplified as it gets. We don't do anything to it. When I did these in high school for Algebra 1, when we went through and factored and factored and factored and factored, doing it tons and tons of times, they did that to us, that we had to say that it was simplified already. I'm not going to do that because I'm testing on actually factoring, and I'm not going to get you stumped where you get to one and you're thinking there's got to be a way to factor it, but it's already done. I don't want you to get stuck there. So I'm not going to put that one on this test because this, again, isn't an actual test of factoring. This is a remembering how to factor because we're trying to gear back up for what's coming next. Okay. So looking at this here, 8, 9, 10, and 11. Any questions on any one of these here? 11. So when we look at 11, 49x to the fourth plus 343x to the third plus 7x squared. So again, when we look at any of these, we want to see, is there a greatest common factor? 7 will go into all three numbers. And we also have what? X squared. Those 49, 343, and 7 are all divisible by 7. And all three terms have at least two x's, x squared in them. And we're going to factor it out. Well, 49x to the fourth, and I factor out 7x squared, or I divide it by 7x squared. 49 divided by 7 is going to be 7. X squared, x to the fourth divided by x squared. Or if I take two x's away from x to the fourth, I'm left with x squared. Now 343 divided by 7 is going to be 49. And if I take two x's away from x to the third, I'm left with plus 1. Because 7x squared, if I factor out 7x squared from it, I'm just left with 1 because it factors out completely. Okay. So now we're left with this here. And we need to determine if we can factor it. No.
Because I would be just looking at this and seeing this here, even that I already know that the answer is no, that this is as factorable or as factored as we can go. Because when I look at the factors of the first term, well, I have factors of 7 and factors of 1, yes? Is there any way that I can multiply the factors of 7 and the factors of 1 to get anywhere near 49? Well, no, they're too far apart, yes? Then that's my first kind of indication that this might not be factorable. The other thing we can do is just use the b squared minus 4ac, 49 squared minus 4 times 7 times 1, and plug this in. Now, this will not give us an imaginary number. Because again, 4 times 7 times 1 is not going to make 49 squared be negative. There's just no way that's going to happen. But this here is going to give us a non-repeating, non-terminating decimal. So this here is as factored as it gets. And this will, some of these will show up where you just factor something out of all three terms, and that's it. But I'm not going to make one like 10, problem number 10, where it's not factorable at all, because that is as simplified as it gets. And part of the reason for that is, well, we don't have a theorem for how to factor the sum of perfect squares, and we don't have rational factors even if we did. Because what this would work out to be would be 6x minus 7i times 6x plus 7i, if we were to actually try to factor it. Now, the only reason I know that is because partially I knew what the solutions would be. I worked this out yesterday for somebody and kind of remembering what those are. And because of the fact that we have the 7i in both spots, it's not factorable. Because to actually get these factors, we would have to either use trigonometric properties, sine, cosine, tangent in the complex plane, which we have not learned and we're not going to cover in this class. So these here don't factor. This is as simplified as it gets with real factors or rational factors. We're not going to be trying to factor this with irrational, with square roots or imaginary terms. Any other questions on these four here? Questions on 12 through 15? 15. 13. Okay, let's look at problem number 13. We have 375a to the third plus 192b to the third. Now, I have a feeling most likely you've already tried taking the cubed root of both. Yes?
and you got decimal answers. Okay. Now we know if this is factorable, and it is, that we need the cubed roots to come out to be whole numbers, yes? And since they didn't come out to be whole numbers, well, let's look back at the numbers. Is there a greatest common factor between 375 and 192? There is, and it is 3. So we can divide both of these by 3. 375 divided by 3 is going to be 125. And 192 divided by 3 will give us 64. So here it was factorable. It is factorable. It's one of our sums of perfect cubes. But we needed that greatest common factor pulled out, because once we pulled that greatest common factor out, okay, well, 125 is a perfect cube, because we saw that the other day. Yes, and it is 5. Now I'll write this over to the side so you can see it. The cubed root of 125 is, well, we can say a cubed. The cubed root of 64b cubed is, well, 4b. These are perfect cubes, so this will work. I put them over to the side because I'm going to run out of room, and I know it. So we can do our 3 and 5. Now the signs are going to be the same, so it'll be plus, minus, plus. Same, opposite, always end on a positive note. Now the first set of numbers I'm going to plug in is the 5a. So we'll have 5a, 5a squared, and in the middle we'll have 5a. Now our other term is the 4b. So we'll have 4b, 4b, and 4b squared. Okay, I have a feeling most of y'all still have space to write here. Yes? Okay, I'm going to have to move down because I ran out. So we'll have 3 times 5a plus 4b. Because the sum and difference of perfect cubes, the first set of parentheses really doesn't change. Well, 5a squared. 5 squared is going to be 25. A squared is just a squared. Minus, well, 5a times 4b. 5 times 4 would be ab, plus 16b squared, because 4 squared will give us 16, and b squared is just, well, b squared. And this is it here. If you put this here, I know I erased the 3. If you put this here as your final answer, you will lose points. You have to have that 3. If you pull out a greatest common factor and then continue factoring later on, it is part of your answer. It is part of the answer, and I do attach points to having the greatest common factor if there is one. So making sure to factor that out. Any other questions on these 4 here? Are we good with these 4 here? Yes? Are we good with these sum and difference of perfect cubes? Okay. Questions on 16 through 18. 17. This here is actually the same as the last one we did. So it would be the difference of perfect cubes. And if we cubed root it, our first term would be 2x and our second term would be 3. And we can do that. So 3 spots and 5. So the signs would be the same, opposite, always end on a positive note. We'd have 2x, and then here we'd have 2x squared and 2x. We'd have 3, 3, and then 3 squared. And I know I jumped through that one pretty quick. It will work out to be 2x plus 3. Well, 2x squared is going to give us 4x squared. 2x times 3 is going to be 6x plus 9. That kind of answer your question? Awesome. Any other questions on these here? Because I don't mind doing those, but 6, 18. Okay. Yeah, so a lot of those, especially with these cubes, look like they should be different depending on how the numbers look, but they're going to be following that same pattern. As long as we can take the cubed root of both of them, then they'll follow that pattern. Okay. I'm going to erase this here so I'll have more room. All right. Let's look at number 18. 6x squared plus 53 minus 9. Now, there's not a greatest common factor between all three. I mean, there is a 6x squared and 9, but the 53 kind of throws us off. Yes? Okay. Two sets of parentheses with 3 spaces. Now, because the 9 is negative, the signs are opposite. So we automatically put one positive, one negative. Now, x squared is going to give us x and x for the factors, because we know that. So we're looking at factors. So the factors of 6 are 1 and 6, 2 and 3. Factors of 9 are 1 and 9, and 3 and 3. So now we need to see what factors of 6 do we want to use, 1 and 6 or 2 and 3? Okay, 1 and 6. How about the factors of 9? Well, I can't put 9 here because 9 and 6 have common factors, yes? Okay. So we can do 9 and 1. So let's try this and see if this works. Well, x times negative 1 will be negative x. 9 times 6x will be plus 4x, which negative x plus 54x is positive 53x, which is what we wanted. And these here are our answers. Questions on this? Yeah, 1 and 1 is fine. Yeah, the only factors that we work are kind of anything besides 1 and 1. As long as they have a number divisible being both of you, as long as they have a division or a factor that's divisible by both of them other than 1, then we're good. Questions on this here? Questions on 19 through 22. 19. So we look at 19. Is there a greatest common factor between all three terms? There is, because they all end in an even number, so it is divisible by at least 2. But it's not just divisible by 2, it's actually divisible by 4. 4 will definitely go into all three terms. And we'll see here. We might have another, because 4 factored out of 40x squared, 40 divided by 4, will leave us with 10x squared. Plus 172 divided by 4 would be 43x minus 9. And that's it. That is the biggest factor. Because we could have looked and see if there was another factor of 2 or another common factor, but there's not going to be one between 10, 43, and 9. So 4 was the greatest common factor. I have a feeling that most likely this will factor, so we're going to go on and give it a try. So with two sets of parentheses with 3 spaces. Now, because the 9 is negative, our signs are going to be opposite. One's going to be positive, one is going to be negative. And when we look at the factors, well, factors of 10x squared, well, we can go on and put x and x. And we'll be looking at the factors of 10, 1 and 10, and 2 and 5. The factors of 9 are going to be 1 and 9, or 3 and 3. Which one should we use? Okay. Yes. Yes. And how about the factors of 9? I'm going to go with 1 and 9. 3 and 3, if we tried this here, it's not that it's a bad choice to use 3 and 3. It's just I don't think the numbers are going to be big enough for us to use here, because 2x times negative 3 will be negative 6x, and 3 times 5x will give us plus 15x, which would be 9x. So it's a little bit on the small side. It's not a bad choice to use 3 and 3. Yeah, so it's not wrong to do that. I would try it, and then try, since it doesn't work and flipping it won't make it any bigger, we can try 9 and 1 and see if that works. Now 2x times negative 1 would be negative 2x. 9 times 5x is going to be plus 45x, which will give us 43x. Yes, which is the correct answer. Any other questions on this here? So we're good with 20, 21, and 22. Yes? 22? This here is going to be the difference of perfect cubes. Now, looking at this here, there is a greatest common factor, because we have to factor out at least y, because there's a common term of y in both. And I can't remember if we can take the cubed root of either one of these numbers. 31250. Nope. So, second, cube root of this. Okay. So what I do is I look at these two numbers. Well, they're both divisible by at least 2, yes? So what I'll do is I'll factor that out and see what the numbers are. So if I factor 2 out of this, I get 1, let's see here, 15, 6 to 5, x to the third. Because we also factored out y. We factored 2y out of it. Now we look at the next number, and we factor 2y out. Well, we'll have 4, 6, because 4, 8, 1, and 3 would be 6, so 12, 6, 5, 6. 93312 divided by 2. So, and what I did is I factored that 2 out, or you can do this in a calculator. So taking the cubed root of 31,250 didn't work. Well, I know they're both divisible by 2, so on the calculator I'll divide it by 2, take the cubed root of that number. If that gives me a whole number, okay, greatest common factor of 2 is all I needed, and I can move on from here. If it doesn't, okay, let's try another common factor, something bigger, because we're trying to find perfect cubes, so we're going to keep simplifying it till we hit a perfect cube. These are perfect cubes. Cubed root of 15,600 25x cubed is, it's either 25 or 36. It is 25x. And the cubed root of 46,656 is our 36. So these are perfect cubes. We just had to factor out that term first, because once we got that factored out, then we can move on. 3 spaces, 5 spaces. Now, our signs are going to be the same. Opposite always end on a positive note. Now, our first set of terms is going to be 25x. Here we'll have 25x squared. Here we'll have 25x. And then that's it. So for our first term, 25x, it's only going to be really filled in 3 spots, and one of those will be squared. Now for the other spot, we have 36. 36 times 36, and here we'll have 36 squared. So even though we factored the 2y out, we're still going to get pretty big terms. 2y times 25x minus 36. Okay, well 25 squared is not one that I have memorized. It is what? 625, sorry. I've got, you're good. 625x squared plus 25 times 36 should be 900x plus 1296. And this here is our answer. Now we did get pretty big numbers for this here. But hopefully you're kind of seeing that the overall process for this here isn't any real different than what we had before. It's just finding these numbers. It's finding these numbers. And once we find them, we can plug them back in. So any other questions on these here? We good with these here? Yes? Okay, well, I'm going to draw a line. Questions on 24 through, or 22 through any of these 4 here? Apparently I can't read the board. Questions on 23 through 26. 25, okay. So this is the last type that we kind of talked about, was grouping. And normally what we can do with these here is we can group the first 2 and the second 2. So 25v cubed and 5v squared. What we want to do is see if there's a greatest common factor between these 2 terms. And well, there is. And it would be, well, 5v squared, because 5 will go into both 25 and 5, and v squared will go out of both v cubed and v squared, yes? Well, if I factor 5v squared out of 25v cubed, I'm left with 5v plus 1. Because 5v squared factored out of 5v squared, well, that leaves us with 1. Whenever it factors out completely, we have 1. Plus 6, 30v, and 6, the greatest common factor is 6. So when I factor 6 out of 30v, we'll have 5v. And 6 factored out of 6 is going to give us 1. Questions on this here? Now, because these are in common in both, we can factor it out again. So we have 5v plus 1. And we factored out of the first term, all that's left is our 5v squared. And we factored out of the second term, all we have left is 6. And that's it. Questions on these here? We good with 25 and 26? Yes? Because on those there, when we have those four terms, we're looking for the first two and second two terms, first and second, third and fourth, and see if there's the greatest common factor. And when we do, what we're hoping is once we factor it out, the sets of parentheses will be the same. So we can factor it out again and get to our answer. So any questions on these four here? We good with these four here? Yes. And that is it. So if you have any other questions or run into something, please ask me, get in contact with me. Your test is tomorrow. So your test over this is tomorrow. So you do have, yes, oh yeah. So you do have your